strong enough to bend one of these pieces of steel? With heat and special equipment, it is possible actually to bend steel. But what about this wooden log? How would you go about splitting it? This sharp axe easily cuts through this log. But what about this ice? How would you go about cutting it? This powerful chainsaw is designed to cut through hard objects like ice easily. But what about this strong piece of nylon rope? How do you go about breaking it? This high temperature flame can be used to divide the rope by actually melting it. The reason these substances are so strong and difficult to bend, break, cut, or burn has to do with the arrangement of atoms and the bonds between them. A chemical bond is an attractive force that holds atoms together. Chemical bonding is the process of atoms combining to form new substances. During the next few minutes, we are going to explore how atoms bond and the different types of bonds they form. Understanding the structure of the atom is important in understanding how chemical bonds form. This substance is limestone, a rock found in the earth. Limestone is mined in quarries like this one and is used in a wide variety of products. For example, limestone is an important component in cement used in building all types of things. The major element in limestone is calcium. This is a calcium atom. At the center of the atom is the nucleus. In the nucleus are two types of subatomic particles called protons and neutrons. The orange particles with the plus sign are the protons, and the blue particles with a neutral charge are the neutrons. The nucleus carries an overall positive charge. Orbiting the nucleus are negatively charged particles called electrons, seen here in red. The negatively charged electrons balance the charge of the positively charged nucleus. This makes the overall charge of the atom neutral. In order for the atom to maintain an overall neutral charge, the number of electrons must equal the number of protons. Here, in our calcium atom, we have 20 positively charged protons that are balanced by 20 negatively charged electrons to make the overall charge 0. Electrons hold specific positions orbiting the nucleus. We refer to the position in which electrons orbit the nucleus as an energy level. Each energy level can hold only a certain maximum number of electrons. The first, or innermost energy level, can hold no more than 2 electrons. The second energy level can hold as many as 8 electrons. And the third energy level can hold as many as 18 electrons. Larger elements have many more energy levels than just 3. For example, gold has 5 energy levels. Energy levels fill up with electrons, starting at the innermost energy level and work outward. The electrons in the outermost energy level are referred to as valence electrons. The valence electrons are very important in determining how an atom bonds with other atoms. Matter tends to exist in its lowest energy state. Matter in a higher energy state tends to be unstable. Matter, such as this salt, in its lower energy state, tends to be more stable. If matter, or an atom, is stable, it is not likely to form bonds with other atoms. But if an atom is unstable, it will have a tendency to form a bond with another atom. Let's take hydrogen, a gas common in the atmosphere and in the air we breathe. Hydrogen has 1 electron in its energy level. But as you recall, the first energy level is capable of holding 2 electrons, and therefore hydrogen needs a second electron to become stable. It can combine with another hydrogen atom so that both atoms have their energy levels complete with 2 electrons. Valence electrons in the outermost energy level determine an atom's stability and how it will bond with other atoms. When the outermost energy level of an atom, such as neon, if this sign is full, it is very stable. Helium, another stable substance, is a gas that is lighter than air and makes this helium-filled balloon float. Helium has its outer energy level full with 2 electrons. But elements, such as copper seen here, in which the outermost energy level is not filled with electrons, are less stable and are more likely to form bonds. Let's take a look at common types of bonds: ionic bonds, covalent bonds, and metallic bonds. The first type of atomic bonds we will discuss are ionic bonds. An ionic bond is a bond in which one atom gives up one or more electrons and another atom accepts the electrons. Ionic bonds are quite common. Concrete, seen here in this sidewalk, is held together with ionic bonds. Lime, often used to change the chemistry in soil, is held together with ionic bonds. Why does ionic bonding occur? As we discussed earlier, bonding is largely influenced by valence electrons, the electrons in the outermost energy level of an atom. And those atoms tend to bond with other atoms to make their outer energy level full, and thus become more stable. In this burning piece of metal, an atom of magnesium with a small number of electrons in its outermost shell donates electrons to an atom of oxygen that needs those electrons to fill its outer shell. Here you can see an atom of magnesium with 2 electrons in its outermost energy level, and an atom of oxygen that has 6 electrons in its outermost energy level. These atoms form an ionic bond when the magnesium donated its 2 electrons to the oxygen, so that the oxygen's outer energy level became filled with 8 electrons. When the magnesium donated the electrons, it became positively charged. When the oxygen gained the electrons, it became negatively charged. Atoms with a positive or negative charge are called ions. In our example, the magnesium is written 2+. It has a positive charge because it has lost 2 electrons. The oxygen is written 2-. The oxygen has a negative charge because it gained 2 electrons, but when the magnesium and oxygen combined to form magnesium oxide, it has an overall neutral charge, with the positive and negative ions canceling each other out. Let's take 2 chlorine atoms, for example. Chlorine has 7 valence electrons. They both need 1 electron to fill their outermost energy level. It is possible they can share a pair of electrons so that both atoms have a full outer shell. This is called a covalent bond. A covalent bond is a bond in which atoms share electrons. We can show this through a diagram called an electron dot diagram. An electron dot diagram is an illustration that shows just the valence electrons of an atom. For example, the electron dot diagram for the bond formed between 2 atoms of chlorine looks like this. Another example of a covalent bond occurs between hydrogen and chlorine, where hydrogen has 1 electron and chlorine has 7 electrons in its outermost shell. You can see from the diagram that each element has filled its outermost shell, enabling the molecule to be stable. Compounds made of covalent bonds are quite common. The major nutrients in foods, such as carbohydrates, fats, proteins, and this piece of fruit, are made of covalent bonds.